Trigonometry Unit Section 2, determine an angle given the ratio. If you know the, for example, sine ratio, you can determine the size of an angle. In essence, you're like a detective working backwards using clues to solve a mystery. So if we're given a right triangle and we measure the opposite side and the hypotenuse, and we set it up using the sine of an acute angle in a right triangle, which is defined as the ratio of the opposite over the hypotenuse, again regardless of the size of the triangle, and that result simplifies to this ratio, we could look up that ratio and see where it corresponds with the size of the angle. And if you've found it, 0.94, the ratio of the opposite and the hypotenuse side in a right triangle with that reference angle A, it will correspond with an angle of size 70. So essentially we're playing Jeopardy. They're giving us the answer and asking us what the question is. We're working backwards. Now this is using a table. If we use our calculator, the preferred method, provided you have a direct algebraic logic calculator, you will hit your second, sometimes it's an inverse, to activate what's above the sine key. If you look at your sine key directly above it, there will have printed there sine to the -1 power. That's the inverse of that function. And whatever color that is, look for that key. And here we have our inverse or second function in gold. The printing above sine would be in that same color. Next, with your direct algebraic logic calculator, you then enter your ratio and you hit equals to give you the value of the angle in this right triangle. If you have a traditional scientific calculator, your order is slightly different. You will enter your ratio first and then activate your inverse sine, which is what's printed above the sine key, by generally hitting the second or the inverse key and then the sine key. Once that is pressed, the display will give you the measurement of that angle to answer the question. This same procedure is the same regardless of which of the three trig functions that we are working with. If we have here what angle has a cosine ratio of 0.423, and this could be from a practical application. We have a right triangle. We've measured the adjacent side of the acute angle and the hypotenuse. We set those values up as a ratio and simplified by taking the adjacent measurement divided by the hypotenuse, and we ended up with this ratio of 0.423. Ratios are tied to angles and don't change regardless of the size of the triangle. So we're looking at cosine, and we read down through our list if we were having to rely on a table, and then find the corresponding angle that always will have that ratio. So using our table, we would answer 65 degrees. With the use of our calculator, just like in the previous example, if you have the direct algebraic logic calculator, you will hit your inverse or second key first, press cosine to activate that inverse, which is printed above the cosine key, enter the ratio that's given, in this case 0.423, and press equals to get the angle measurement that we're looking for. And here they're giving us a more exact value than what the table has. So we have an angle measurement of 64.97 with more detail there. If you have the traditional scientific calculator, then you will enter your ratio first, followed by the inverse cosine. And to activate inverse cosine again, you will hit the second or inverse key and then press the cosine key, which is actually getting to the inverse cosine, which is above that key. And here's our answer again with the angle. Practice on this type of skill is found on page 22.